All right, and welcome to the third and last set of notes for our Chapter 4 test. Today we're going to be talking about periodicity or periodicity or periodicity. Hey, you want to hear a joke? Why did Chuck Norris destroy the periodic table? Get it? Anyway. What is periodicity on the periodic table? What it means is this was somewhat highlighted in our last set of notes when we talked about Dmitri Mendeleev, is that there are patterns. There are predictable patterns of properties on the periodic table. Of elements. And there are always exceptions, and that's just a general truism of chemistry. But it allows us to predict how elements are going to behave, and being able to predict what will happen is a pretty important process of science. There are three trends that we're going to look at. The first is what is called atomic radii. It is basically how big is an atom. And this is typically how it is measured in the laboratory, because atoms don't really have a definitive boundary in terms of how big they are. So instead, we bond two atoms together and we measure the distance between the nucleus of both those atoms, cut it in half, and there is your radii. And that's how we figure out how big atoms are. What you need to know for the test is the trend. So atoms get smaller as you go to the right, and they get bigger as you go down. Another way to remember this is francium is the biggest, fluorine, or I should say helium, is the smallest. Okay, you can either remember the trend or just remember what elements are the biggest and smallest, because if francium is the biggest, then as you go up or as you go over to the right, they have to get smaller. So if you just remember it's the biggest, you kind of can logically figure out the trend. Why? And this is important. You will be asked this on the test. Why do atoms increase as they go down? Well, the reason they increase is because as we add electrons, we add them to rings. We're adding rings to our atoms. If you remember from 9th grade physical science, you have your nucleus in the middle, you have your first ring, energy level, you have your second ring. Well, as we go down the periodic table, we're adding rings, and so the atom gets bigger. But as we go across, why do they get smaller as we go across? Well, it's because we're not adding rings. And what happens as we go across, the magnetic attraction between the positive nucleus, because the only thing in the nucleus are protons and protons are positive, neutrons are neutral, and the negative electrons, opposites attract. It's a universal truth. As we go across, because we're not adding rings, the positive nucleus is becoming more positive, and the attraction between the nucleus and the electrons is stronger. And so what happens is the atom gets pulled in tighter and tighter and tighter. Just like a stronger magnet pulls things in more, the same is true as we go across. Throughout all the rest of the trends, or trend number 2 is ionization energy, that magnetic attraction is going to be the fundamental reason of why these trends happen. So for ionization energy, this is the energy needed to remove the outermost electron. So whatever electron's on the outside, how much energy does it take to take it off? As you go across, it gets stronger. It takes more energy as you go across, and it takes less energy as you go down. Why? Well, think about francium. Francium is huge. Imagine francium, it's sitting on this giant pile of candy. Wouldn't it be pretty easy to just go up and take a piece of candy? But helium, it's incredibly hard. Helium only has like 2 pieces of candy. If you wanted to go up and take a piece of candy away from helium, but it only has 2 of them, don't you think it would be pretty hard? You'd have to wrestle with helium to be able to take it away. So that's the reason why. So as you go across a period, atoms get smaller because the attraction is stronger. So it takes more energy then to remove things. As we go down, the attraction isn't as strong because atoms are big, and so it doesn't take as much energy to remove an electron. And the last trend, electron affinity. Electron affinity is very, very similar to ionization energy, the previous trend. It's slightly different. You can see by the definition, it's about the energy released when an electron is added. So ionization is about the removal of electrons. Electron affinity is about the addition of electrons. But the trend is still the same as ionization energy. It increases as you go across. It decreases as you go down. Why? The same reasons as before. As you go across, atoms are smaller. The attraction is more. It's easier to add an electron. As you go down, the atoms are huge. The attraction isn't as strong, so it becomes a little more difficult to add an electron. Okay. I'll leave that on here in case you want to write it down, so you can pause the video to do that. But basically, if all you remember is atomic radius, just remember the trend of atomic radius, and then the other ones are just opposite. So atomic radius was francium is the biggest, so it gets bigger as you go down. They get smaller as you go to the right. If you can remember that, just know that the other trends are just the opposite. All right, so let's practice. So this is similar to what you're going to see on the test. You're going to be given elements, and you're going to be asked to rank them like this, or it might be what element in group 2 has the largest atomic radii, or what element in period 3 has the lowest electron affinity. So you need to know the trends. Obviously, you need to know groups and periods, but you just follow the trends for atomic radii. Atoms get bigger as you go down. So lithium, cesium, potassium are all in the same group, up and down. They're in group 1. So atoms get bigger as you go down. If you know that, remember, the other 2 are just opposite. So we know that ionization energy and electron affinity are just backwards. Here we have lithium, nitrogen, and carbon. So these are all in the same period. They are all in period 2. But you'll be asked the same question. How do they rank for atomic radii? Blah, blah, blah. So if you didn't do it on the last one, go ahead and pause the video and try doing this, and then we'll go over it. So hopefully you paused the video. And so if you know the trend, atoms get smaller as they go across. So nitrogen is the smallest, carbon is medium, and lithium is the biggest. So we're writing these in order of increasing size. So the atom should be getting bigger. And again, if you remember the atomic radii trend, the other 2 are just backwards. So hopefully that helps. And that's it.